it's pretty much a guarantee that you're going to see a problem like this on the SAT. It's basically just about angle relationships. So what we'll do is we'll go to the big board, look at our given information, and take each of our answer choices one by one until we figure out what's true and what's not. So here's our diagram recreated on the big board, and here is our one piece of given information. Angle PQR is congruent to angle ABC. Hopefully you know your angle relationships. Certainly you saw this in geometry class at some point. These are alternate exterior angles, and because these alternate exterior angles are congruent, it follows that these two lines, BC and PQ, are parallel. Next, we're asked to determine if the measure of angle ABC plus the measure of angle XQP, that's this one right here, we're asked whether or not those add up to 180 degrees. Continuing with our reasoning from answer choice A, if alternate exterior angles are congruent, it is also true that alternate interior angles are congruent. Anytime two angles come together to form a straight line, those two angles are supplementary. They are coming together to make half a circle, to make a straight line. They are adding together to equal 180 degrees. So if these two angles add up to equal 180 degrees, it stands to reason that this angle plus this angle will also add to equal 180 degrees because these two angles are the same. Next, for answer choice C, we're asked if triangle BXC is similar to triangle QXP. Vertical angles are congruent. These two angles right here are vertical, so they must be congruent. Two angles that are congruent from one triangle to the next, then you've got similar triangles. And at this point, by process of elimination, the answer has got to be D. There is no way triangle BXC can be congruent to triangle QXP in all cases. And there's a really easy way to show that, to convince yourself that that's true. And that's just to move one of these two lines. So here we've got the exact same situation, just drawn a little bit differently. PQR is still congruent to angle ABC. Since alternate exterior angles are congruent, PQ and BC are parallel. Since BC and PQ are parallel, alternate interior angles are also congruent. And by vertical angles, angle PXQ is congruent to angle CXB. Same diagram. But one glance at the two triangles is proof enough to see that these two triangles are not congruent, while they do still maintain their similarity because of their equal angles. So statement A is true because of alternate exterior angles. Statement B is true because of alternate interior angles and supplementary angles. Statement C is true because of the angle-angle similarity property of triangles. So by process of elimination, we're drawing an alternative diagram that still maintains these properties. The correct answer is D.